Hello friend, welcome to GNT's YouTube channel and today topic is Neuromorphic chips, how brain inspired computing will transform AI. So start our topic. Artificial intelligence has reached a critical crossroads with AI capabilities continue to expand exponentially. The underlying computing infrastructure struggles under mounting pressure. Traditional silicon chips engineered decades ago using known architecture were never designed for today's AI workloads that demand massive parallel processing and real-time learning capabilities. The numbers tell a stark story. Turning a single large language model can consume as much electricity as 300 homes use in an entire year. Meanwhile, the human brain and nature's most sophisticated computer processes complex information using rudely the same power as a 20 weight light bulb. This dramatic efficiency gap has sparked a computing revolution. Enter neuromorphic chips, a groundbreaking technology that abandons conventional computing principles in favor of brain-inspired architectures. This revolutionary processors don't just promise in sentimental improvements. They represent a fundamental paradigm shift that cloud make AI more powerful, efficient, and accessible than ever before. What are neuromorphic chips? Neuromorphic chips are advanced microprocessors engineered to replicate the human brain's neural structure and information processing methods. Unlike traditional computers that separate processing until from memory storage, this innovative chips integrate both functions into a unified architecture mirroring how biological neurons process and store information. At their core, neuromorphic chips consist of artificial neurons and working in harmony. Each artificial neurons functions like a biological brain cell, receiving input signals, processing information, and generating outputs. Artificial synapses serve as the connections between neurons with their strength adjusting based on user patterns are digital representation of how human learning occurs through repetition and experience. Key architectural innovation. The most revolutionary aspect of neuromorphic computing lies in its event-driven processing model. Traditional chips operate on rigid clock cycles, constantly consuming power regardless of computational demand. Neuromorphic processors, however, only activate when receiving a specific input, a single signal, implementing what researchers call speaking neural network (SNNs). This operation allows different sections of the chip to work independently at optimal speeds, similar to how various brain regions process information simultaneously without central coordination. The result is a computing system that's inherently more efficient and neutrally suited for a parallel processing task. The brain as computing blueprint. Human brain architecture represents for a billion year of revolutionary optimization, weighting approximately 3 pounds. The brain contains roughly 86 billion neurons connected roughly trillions of synapses, creating a network so complex that it drops any artificial system can constructed. What make biological neurals network truly remarkable is their combination of massive parallel processing with extraordinary energy efficiency. The brain processes visual information in milliseconds, recognizes faces instantly, learns from single examples, and adapts to new environments, all while consuming less power than a standard laptop computer. Biological principles driving innovation. Uh, the brain's ability to strengthen or weaken connections between neurons based on experience forms the foundation of learning and memory. When you practice a skill, relevant neural pathways become more efficient and repeated activation sparse coding. Unlike digital computers that process every bit of data, brains use sparse representation. Only a small percentage of neurons activate for any given input. This selective activation dramatically reduces energy consumptions while maintaining processing effectiveness. Temporal dynamics. Biological neurons communicate through precisely timed electrical pulses called action potentials. This temporal encoding allows the brain to process information about timing, rhythm, and sequence capabilities. Traditional digital systems and struggles to replicate efficient encodings. To research polished in natures and others, humans' information capabilities approximately operations per second while consuming others. So friends, my topic is complete. See you in the next video. Take care. Bye.